Hello students, this is going to be the third and last video for exercise 4.2 from our textbook, and this is getting into some of the slightly more challenging questions. So I'm going to do a couple of these, but a lot of them I'm going to leave them for you to have a go at, because that's how you're going to learn to do questions like this, is try them. Okay, look at question 16. My suggestion is stop the video, read the question, try the question on your own, and then come back and check your answer. So, a right-angled triangle has a side length of 2 centimeters, a hypotenuse of c centimeters. So that's the triangle over here. Hypotenuse is c, one side length is 2. An square of area a square centimeters is drawn on the third side. We're going to stop here and think for a little bit. If that has an area of a, and this is a square, then that side by that side must equal a. So this must in fact be the square root of a, because the square root of a times the square root of a equals a. So we know the expression for that side is square root of a. And we're trying to find a formula for c as a function of a, and then graph the function for areas up to 60 square centimeters. Okay, so hopefully you've had a go at this, so let's see how you went. Okay, first off, because you know that that side there is the square root of a, that's c and that's 2, hopefully your brain said, oh, this is Pythagoras, because we know something about the 3 different sides of a right-angled triangle. So hypotenuse squared equals one side squared plus the other side squared, and that's what I have just there. Okay, let's do some simplifying. Well, the square root of a squared is just a, 2 squared is 4. And to get the c by itself, take the square root of both sides, and I rewrote 4 plus a is a plus 4. So there's the actual formula for c as a function of a. So not too hard, but again, getting from the words to the equation to the final answer does take a little bit of thinking and a little bit of practice. And just from the back of the textbook, there's what the graph looks like. Okay, let's move on to the next. We're not going to do the next question. I suggest you have a go at question 17. It's not particularly difficult. The math is much the same. You just have to go from the words to the math itself. That's what makes it slightly challenging. Question 18, we've done questions similar to that, so my suggestion is try at least one of those and see how you go. Obviously, C and D are the slightly harder ones. Similarly, for question 19, well, we actually did one of those where we had a negative underneath the square root. So you can try those as well. We've done one similar to that. The one that they said to use the calculator for, I actually did it using algebra, so that's going to help you for this question. And this one we are going to get you started, because this one's actually quite difficult, relatively speaking. It's a fairly complicated looking function. So sketch the graph of the function showing the coordinates of each major point, vertex and intercepts as relevant, and determine the domain and range. So all I'm going to do here is give you a start, because this is different to what we've done before, and then I'm going to leave it up to you to try to finish it. Okay, so the main thing that's different about this equation is we've got a number in place of b, which we don't actually have in the general transformation function. So what we can do with this is I can actually move that. I've got a square root of 2 there as a factor of this whole expression underneath the square root. What I can do with that is I can actually take the square root of 2 outside of the function. And if you say, well, why can you do that? That's because of this. If you've got the square root of a product, you can write it as the product of the square roots. So in this case, I've got -1 times 2 times all of that. So 2 is a factor. So I can basically take the square root of 2 on the outside. So now that becomes A, that becomes C, that becomes D, and you got to flip the graph in the positive y-axis. So that's your hint for question 20. And finally, I'm not going to give you any hints on question 22. Again, it's quite challenging, but it's definitely worth having a go at trying on your own and checking the answer. So good luck on question 22. And that is the end of videos on section 4.2.